We present our system for improving information sharing and collaborative analysis for remote geospatial visualization using mixed reality. Our system starts with a 3D US map component as the foundation of our immersive visualization. It serves to interactively select individual states for filtering data. We also provide interactive holographic layers of US map consisting of outline of the map and respective states. They allow to overlay multi-attribute data on top of them, visualize in physical space around. User can use hand gestures to manipulate the holographic layers like rotate, scale, and reposition them. The example dataset we used allow filtering based on carcinogen or metal releases and whether the facilities are federal or not. We also provide options to filter the datasets based on top 10 chemical releases and top 10 industries based on their aggregated releases amount. User can further filter the visualized data by filtering based on the desired US states user wants to focus on. You can also visualize the foundation map horizontally, simulating the large map placed on a table or floor. Here, user creates a new layer and show data points of all top chemical releases and repositions the holographic layer on top of the foundation map. User can also visualize the height of states based on the accumulated chemical releases for each specific state. Here, it shows that state of Nevada, though has less number of industries releasing those chemicals, but the accumulated release amount is greater than any other state. We provide effective feedback regarding which object within visualization the user is gazing at. At basic level, we only show the gaze of current user. Here, the gaze is used to highlight the US state the user is gazing at. Apart from this, we provide high-level and low-level gaze sharing between collaborators. An avatar is used to accurately visualize the relative position and orientation of remote collaborator. Here in low-level gaze sharing, we highlight the outline boundary of US state the remote collaborator is gazing at, and the gaze of current user is shown in different color. Here we show the same low-level gaze sharing between collaborators but from point of view of the remote collaborator himself. The remote collaborator can similarly view which objects within the visualization other user is gazing at. Finally, we also provide option to view high-level gaze of remote collaborator as it shows the exact location and the object within visualization the collaborator is gazing at. It renders the accurate gaze location in real time relative to the view of current user. Here we show the same high-level gaze sharing between collaborators but from point of view of the remote collaborator. Here we show two remote users collaborating and sharing information visualization when performing visual analytics tasks. Here, user A creates multiple holographic layers and applies different data filters on them. After observing something interesting in the visualization, user A shares the holographic layers with user B using voice commands. Here we can see in real time updates in the physical movement of remote collaborators with the help of the avatar. Now user A wants to explore the data more but yet does not want to share it with the collaborator. Thus user keeps the visualization in his local space. Here we show the point of view of user B who is observing different aspects of the dataset. Here user B can also track the movement of user A, giving the sense of co-presence while observing and collaborating remotely. User A now shares the visualizations with user B and they are positioned relatively to the user B. User B can now remotely observe the same visualization that user A found interesting. To further enhance the process of collaborative sense making, we expand our design to facilitate distributed cognition by allowing user to revisit important interactions in the visualization, leading them to final analysis results. The different history instances are shown in form of avatars which record the exact position of user when the history instance was recorded. In this example, User has created three history instances and he revisits them one by one individually. The green cone represents the current history instance under observation, and the color of avatars represents the chronological order of the history instances. User can switch between history instances by interacting with the avatars or using voice commands. After performing multiple visual analytics tasks to understand the dataset, user can also switch to high-level or low-level provenance visualization using voice commands to understand how the analysis process has evolved and revisit the history instances in a single visualization. Here we show the low-level provenance visualization. Finally, user can choose to view high-level provenance visualization as well.